Okay, so today we're going to be starting to use some new Python libraries that are mostly to do with data science. So data science is a huge field, and it's kind of very new. It's very modern, very current, and a lot of it has to do with not only being able to process large amounts of data, but to draw conclusions from it. And Python has a few libraries which are extremely powerful and perfect for this use. So if you end up going into data science, you will almost certainly be working in Python. Python is the most popular data science language today. So the names of these libraries, and you can install them now if you haven't already with pip. So we have pip install pandas, which unfortunately does not actually give you a panda. Pip install numpy, looks like numpy. There's also one called scipy, scipy. Oh, pip install scipy. I already have all these. And the last one is called Jupyter, but spelled with a py because, there's a theme with Python. Yeah, so I'm actually going to write these up here. So pandas, numpy, scipy, and Jupyter. So today is going to be just a very general introduction to these libraries and how they're used. In the coming days, we're going to be kind of going into more about what they're used for and how data science works, and as a kind of go and take a deeper dive into that. Right now, I just want to help get you familiar with these. So first off, Jupyter. Jupyter is actually a kind of notebook. It's like an interactive notebook that allows you to have plain text and code all in one place. It's very, very cool. And actually, so I have this file here called data science 1.pynb, which IPYNB, it doesn't really want me to look at it for some reason. That's okay, it's not really human readable. That's what Jupyter is for. What I'm going to do is I'm going to type in Jupyter notebook dot, and in my browser, it opens up this thing, including the README, the Python file, and it'll give me a readable version of data science 1.ipynb. So I click on that, it opens a new tab with all this stuff. Now I'm going to be taking this away because this is actually where my notes are, but as you can see, it has everything formatted in a really nice, readable way. So we're going to go into more detail on Jupyter later. Just wanted to show you how to open it and what it does. But we're going to be talking about how to use the other libraries here to more of an extent. So kind of the most basic thing we can use these libraries for is for helping us with math, particularly with math that has to do with data sets. So for example, we're going to talk about, kind of some of the basic math things about how to deal with like a list of data sets. So for example, here, I'm going to copy this. I'm going to call them, these are heights of people. So this is an array of some heights of adult males. So first off, one thing we need to keep in mind is the sample size. So what is sample size here? Like not what is it, but like what is the sample size?
Length of heights.
Yeah. So it's this how many samples we have or it's how many items we have in our sample, the number of subjects. So we want to calculate that. We can just do len of heights. What about the range? What is the range?
The average results.
No range.
Okay.
It's, yeah, so the range of something is the highest number versus the smallest number. So again, we don't need the libraries to calculate this. We can say range equals max of heights minus min of heights. This list is already sorted as well, so we could also do 0 and -1. It would still do that. How about the, let's see, how about the, what would the mean of something be?
That's the average.
Yeah, that's the average. How do you calculate that?
AVG parentheses heights. I'll try that.
I mean, mathematically.
You would sum it all together. Just
Middle divided by number of items.
Yeah. So it's the sum of all the samples divided by the
Number.
number of all the samples. And so there are a few ways to calculate this, and this is where we may want to use numpy. So I'm going to do import.
We could also use the reduce function from iteration, right?
Yep, there's a lot of ways we can do that, but to calculate the mean easily, we can just say mean equals numpy.mean. Heights. And that'll calculate it for us. All right. Who knows what the median what a median is?
The middle number.
Yeah. So the middle number. So so that can vary depending on your sample size. So right here we have 10 things in this, I believe. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So in that case, there isn't really a middle value here because it's an even number. So, yeah, so in that case, we would take the mean of these two middle numbers here. So again, calculating that in just vanilla Python is a little bit tricky because we'd have to change depending on the length.
Get that features.
And we'd have to sort it. So again, we have our libraries can help this out. I believe that's another thing numpy does. Say median equals numpy.median of heights. So let's actually see these in action before we go further. So I can say, right? We know the range and the median work. So mean and median. That. So the mean is 71.1 and the median is 70.5 because 70.5 is midway between 70 and 71. And if you add all of these together and divide it by 10, you get 71.1.
Does numpy automatically, like, when you have, like, if you were to the hundreds place, would it round to the tens?
Good question. We can figure that out. But, blah, blah, blah. Let's see what happens. So looks like it kind of automatically, so since these went out to the 6th decimal place or 5th, one of them went out to 6th, one of them went out to the 5th. So I guess it just went as far as it had to. If it's something, if it's like a repeating decimal, I do not know what will happen then. So that is something that I would have to probably look up in the numpy docs and say, hey, how can I get, if I want to get something to a certain decimal place, how could I do so?
Print pi, see how far it goes.
I don't know. I bet numpy has like a pi function. If not, SciPy does. So numpy, and I think actually SciPy is actually like uses numpy. They're kind of under the same umbrella in some ways. So they have infinity, NaN. I think it just has inf n0. If I just type in pi, positive infinity, can I just get pi? Okay, they have numpy.pi. So let's try that out. So it takes it up to a certain point. It's enough for any real calculation. We don't need it up to the millionth decimal place or whatever.
It also might have it more in the background and instead.
Perhaps. Let's see if they meant to. It looks like they don't have any kind of further thing about how to get more of pi here.
I'm curious if the docs are taking it out further than the actual program is taking it.
That's
Good
why
point.
it might use more in the background, but it's only printing up to certain decimal places. Just
Yeah.
because of what it is.
Yeah, I'm not sure. I mean, generally speaking, I can't think of a situation where you need that many decimals of pi. Like, as long at some point, just the math like this is close enough to the actual thing that adding more decimal places will add a large difference. Space now.
Well, they actually say that they only need a certain amount of digits, and that the mathematical community is doing too much. So.
Yep. Cool. All right. So there's kind of one other type of statistical average called the mode. What is mode?
When it appears most common.
Yeah, the most frequently occurring element. So looking at this, you'd expect the mode to be 70 because we have three 70s here. So this is, I believe, something that SciPy has, not numpy. So I import SciPy. We should be able to say SciPy.mode. Is that what it's called? Pick this up. No. So SciPy has a variable called stats.mode. So again, I'm going to print out mean, median, and mode here. Oh, has no attribute stats. That's weird. It should. Did I do something wrong? So it should be able to say from SciPy import stats. Let's try it this way. And do stats.mode. All right, so you have 71, 70.5, and then we have this mode result object, which has mode equals an array, 70, and it has a count. So it gives us, so there can be more than one mode if we have more than one thing occurring at the same frequency. So in that case, it gives us an array of everything that is the mode and y, like it says, an array. So there are three 70s. That's why it's the mode. I saw something in the chat real quick. Let me check on that. If it'll let me. There we go. Let's see what this is. Thank you. That was very important to this. Beast mode has been activated now. Okay. And then kind of the last thing you'll be dealing with is something that's a little more abstract. This is standard deviation. Standard deviation represents how much variance values are, how much they spread out. I don't really want to get into the details of how it calculates standard deviation because the formula is like the square root of, like if I have like standard deviation formula, let's like look at that.
Distribution.
Yeah. It looks like this. So the population standard deviation is equal to the square root of something about like the mean, each value of the population squared, divided by the size of the population. I don't want to have to do that. Luckily, we have, again, we can numpy has something that does that for us. So we can do S standard Eve equals numpy dot the unfortunately named method std.
Is that y on y?
Thank you. So standard deviation is 3.6180180 Get the idea. So these, like, we're only scratching the surface on what these libraries, what NumPy and SciPy can do. They're highly versatile libraries with a ton of mathematical stuff. So if you are interested in math and data science in general, definitely just go strolling through the docs of these, because they are, for one thing, they are actually very well documented. Like some places the document, that's not it. The documentation is, not all documentation is written equally, but you can see NumPy is pretty easy to read.
Wait.
Yeah. All right, so any questions about NumPy and SciPy, or these very, I want like very standard, not basic, but standard statistical operations?
I have a question in general. So if we're dealing with floats, would it be recommended to import NumPy and use that?
When you say dealing with floats, what specifically do you mean?
Well, for instance, the first assessment when we had the problems with the rounding, would importing NumPy solve that issue?
It might help if we do like NumPy round number. Let's see what it says. They have numpy.round here. Refer to round an area to the given number of decimals. Refer to a round for full documentation. Okay. Evenly round to the given number of decimals. So it takes in input data A, decimals, so the number of decimal places to round to, and out, which is alternative output array for that. So we can actually try this out. So we want to say print numpy.round like to the nearest decimal, like to 2 decimal places. Let's see if I'm using this right. 1.24. Or around.
Due to like it's like recurring thing, like 1 divided by 3.
Yeah, let's try that as well. So 1 divided by 3 to the second decimal place gives me 0.33. If I take away this, so it's only just doing rounding 1.33, gives me 0.0. Because, yeah, rounded to the 0th decimal point, which means it's 0.33 rounded down is 0. Or if I did, 2 divided by 3, my guess is it would give me 1.0. Because 0.6 rounded up is 1. And then if I rounded it to, say, the 3rd decimal place now, I'm going to get 0.667. Yeah, so the numpy.round or around method definitely seems to would solve a lot of problems. Sure. Cool. So, and always remember, whenever you're kind of tackling any kind of problem that seems intractable, you're not the first person to have that problem, and somebody probably made some kind of library specifically to solve it. So maybe like in an assessment, maybe you won't have time for that, but in general, you can always say, is there a library that does this? And find what happens. Cool. Any other questions about NumPy, SciPy, and mean, median, mode, and standard deviation? Okay. In that case, I'm going to comment all of this out and move on to the last one, which is pandas. Pandas is an extremely powerful library, and it allows us to take a data set and render it in a very nicely formatted table that we can then query kind of like SQL. It makes dealing with things so much easier. So I'm going to import pandas. I'm going to import it as PD just so it's shorter. And I'm going to have a big old data set. So this is a list of years, a list of teams, how many wins each team has, and how many losses. So, the first thing in this array corresponds to the first thing in this array, the first thing in this array, and this array, and so on. So that we have an object. So that's the column name. Each one of these is a row, column name, rows, column name rows, column name rows. In order to use pandas, we're going to do is we're going to say, we'll call this football equals pd.dataframe, converting the data. Then we're going to print out this data frame. Clear this. Nice and human readable.
And we use it for CSV files too.
You could, in today's challenge, you'll find out that there is a way for actually using this in CSV files. So it's something we'll get to. So yeah, today's gonna be another day where it's one big challenge, but I think it's an interesting one because you're gonna be dealing with real life data. All right, so we can also figure out if we want to just take a look at just one row. We could say .loc, and then let's say we want to look at the very first one, loc0. It should just give me only the first row. Again, formatted in a nice, easy to read way. So year 2010, team Bears wins 11, losses 5.
Does it freak out if you have an empty value somewhere in the data?
Let's see what happens if I just do extra row here. And then just do football, just print out football. Arrays must all be the same length. So you got to make sure you're cleaning your data before you give it to pandas.
And how about an empty spot?
And my guess is it'll do just like this.
And of course, get rid of other numbers so that it still matches up.
Yeah, or just like that. So I think we'll get the same error because
I was saying you would still have blank space, but just get rid of one of the numbers or change your numbers to a blank space. That way, the number of spaces are the same.
So just like this.
Yes. Is that right?
Yeah, so, yep.
And invalid syntax.
Okay.
If we did replace it with null, or sorry, be none. Let's see what happens because there is. Okay.
So it can take a.
So it gave us NaN for losses here instead of what it was. So it's got to be the same. All the arrays have to be the same length in order for it to work. And we need to you got to be careful what you give it. It'll just convert to NaN if it's not a number and it's expecting a number. Steven, is your hand up? Or
No, I'm sorry.
Okay, just checking. All right, so again, we can use .loc to find one thing. We can also say, all right, what if we just wanted to see the team name and how many wins they had? In that case, so we use square brackets, and inside those square brackets, we put more square brackets. I don't know why it is, just is this way. And I want to have team and wins. So I only want to look at these two columns. Clear this. So it just narrows it down to what the team name is, how many wins they've got.
On line 21, between the very first two square brackets, could you add another square brackets and put 0, see if the just returns 0? Right there, left side. Yeah.
Try it.
And then square brackets, 0 goes square brackets. That's what I would do.
As in, put it like this?
Yeah. Yeah.
Well, let's try it one way and then the other way.
Okay.
Let's figure out which one, because I don't know. All right, so that doesn't work. It's an invalid key. Let's try putting it in the square brackets again. All right, still not working. Pandas has very particular syntax, so it might be something like football.loc 0, and then put team wins here, maybe. Let's see. The chat. Someone has a suggestion. No. Not going to get into that. Let's see if that syntax works. Nope, still not good syntax.
It's what extra bracket.
Extra bracket?
Yeah, the yellow one.
Oh, you're right. Thank you.
I see that too. And we win.
Ah, there we go.
Little winner, chicken dinner.
We got the, no, this gave us everything. All right, so let's see.
I'm sure that after 5 hours of trying, they'll do it.
Yeah. And this is one of those cases where we could keep on trying things, or we could check the pandas documentation and say, well, let's just like pandas documentation for now. Let's see if it has this, because this seems like it should be something basic enough that we should be able to find it pretty quickly. But you never know with pandas, because we never know. Maybe this documentation isn't as easy. User guide. So they have something about CSV and text files. Queries. The indexing and selecting data. So .lc is primary label based. Boolean array.lc will raise key error when the items are not found. Allowed inputs are a single label, selection by label. Not a big fan of it. So do they have any examples? We have a date range. I'm not entirely sure. So they have like the data frame with A and B here, like we did earlier. I'm not sure what this is. LOC : B. Wow. This gets pretty complex. Data science is not a simple field. So I don't want to spend a lot of time going through this right now, just because there's other things I want to get to. There is almost certainly a way to only look at one row and only certain columns from that row. I do not know what it is at this time.
Okay.
But that's a very good question. Because there's a lot of different ways to look through this. So for example, if I want to see, I do know how to find out if I only want to see how many teams have more than 10 wins. So in this case, it's football and then : football again, wins, where these wins are greater than 10. So this gives me only the 2010 Bears, the 2011 Packers, and the 2012 Packers. If I only, okay, so, and if I only want the year and team for those, so maybe this might hold the key, perhaps. We can do year, team in another pair of brackets. So kind of looking at this, we've got football, big pair of brackets, one pair of brackets representing year and team. Or am I doing this wrong again? Sorry, this is also pretty new to me.
Comma?
All right, one sec. I'm going to just copy and paste from my notes so that way I've got the right version and I know I will. And then we can look at it in detail. All right, so get our so brackets, year and team. Then outside, then also football wins 10. So these two brackets are not connected, but they're all inside the print statement. So now if I do this, hopefully it'll work. Ah, okay. So maybe, going back to our earlier query, maybe we could do it this way. Perhaps like this. .loc 0. Darn it. Maybe these aren't in brackets now. If not, I'm just going to throw my hands up on this. Yeah, I don't know. This seems like it should be a very simple thing, and it's not. But we can separate it by saying, give us the year and team of teams where wins is greater than 10. So we're combining these two things. There's also things like if you only want it where it's the Bears. So print football brackets. And inside these brackets, football all dot team equal to the Bears. Yeah, pandas. This is a lot more difficult than I thought it would be the first time I looked at this. Like, let's see if they have a more general guide that can kind of give us some more things. So LOC is primarily label-based, same thing we were looking at earlier. So it's a callable function. So I'm looking at this and it's like, I want to try something else real quick. What do I do? Football, it's primarily label-based. What if I do give me LOC Bears? Will that work, or is it only for data rows? Okay, so LOC is only, okay, so I was right, LOC is only for like the ID, which we didn't give it, it automatically generated.
If your data set already has like a primary, put it in that guide, use that as, or would it still add the index inside?
Good question. We might be able to do like, let's see, if we just print out, first I'm just going to print out the entire table, see if they can tell us how, if it has a label. So it doesn't have a heading here. But let's say we gave it one called ID, set that equal to, would be, so 0, how do you set a range again? 0 dot dot 10? Is that right? Now we got an index thing.
I think you only have values, so you got more range.
Yeah. I also may have done a range wrong. I forgot how to do Python ranges. One sec. Python range. Oh yeah, so let's just do, yeah, duh. Range 10. Had a brain fart there. Forgive.
So you only have 8 or 7 years.
Oh yeah, you're right.
You have more range than.
Thank you. 7. It's taking its sweet time. Okay. Reason was probably all the same length. Did I count it wrong? 1, 2, 3, 4, 5, 6, 7, oh, 8.
Starts at 0.
All right. One more time. Let's see if it'll replace that primary key with our ID number, or it'll just add ID as its own. Yep. So it just adds ID as its own separate column. It generates these automatically, apparently, regardless of what we do. Good question. So looks like we can safely just allow pandas to generate primary keys for us without having to explicitly say so. All right. So I'm going to do one more demonstration of pandas. So what I want to do is I want to get the statistical mean using numpy of all of the wins that the Bears have. So in football, I'm going to check out all of them where football.team is equal to the Bears. And only the wins. And I'm going to dot apply. Do I still have numpy imported? Yep, numpy dot mean. So it's just essentially saying, all right, from this table we have, give me every row, give me just the team name, so give me just the wins where the team name is equal to the Bears, and give me the mean of all of these using this dot apply functions. So the statistical mean for all the wins by the Bears across the years is 9.666667. All right. So again, this is all just kind of scratching the surface of pandas, and like I know this seems like a lot and it's confusing, and honestly, you're not alone in that. The place I used to work at, Flatiron School, had its own entire separate boot camp just for data science. So we're going to be doing a relatively small amount of that, and today's challenge is going to be asking some relatively simple questions, nothing more complex than essentially this line right here. So you're gonna have a lot of time today to play around with pandas, so you can figure that out. Let's see here. I believe we have. All right, I have one more. What's the word I'm thinking of? Resource that may be a little more helpful than what I have been looking at. So looking at the pandas.data frame object here, maybe this link may be a little more helpful for us. They have, you can check the types. They have attributes here, methods like add or apply. So allows you to apply anything around the x-axis, so to a row. Do they have anything about queries and how to do them? Looks like they do not have anything about how to do queries. There's probably a better tutorial out there to go into more detail on how to do each of these. But also this entire, like all of the notes that we went over here, that's all going to be in the README for today's curriculum thing as well, including how to use how to set things up and how to use Jupyter to look at it. Yeah. So I want to thank you all again for being patient about this, because this is pretty new to me, and I went through it all, and like when I was looking through it on my own, it was like, oh yeah, this is simple. And then you guys, oh wait, it's not as simple when I have to explain it to people. So this is going to be taking, so as you're going through today's challenge, which is called Titanic, feel free to ask me questions, because by asking me questions, I'm going to have to learn more about this. So we're both going to improve each other. And let's take a break, have lunch, and then get started on Titanic.
Definitely gonna sing.
Quick question, I might be the wrong